everyone! How are you today? Great! I'm Rosel O. Abulog, your cheerful science teacher. Just call me Teacher House. It's already third quarter of our school year, and I know you're willing and craving to learn more. Are you ready? Let's go! But before we start our lesson, let's put first the presence of the Lord. You can recite, read, and sing the glorious prayer for today. Okay class, settle down. Sit comfortably and properly at home. I'm very happy that all of you are present today. Hooray! Have you remembered our previous lesson? If so, let's proceed to our recall. The title of our recall is Review Analyzing. You have to identify the pictures posted on the screen. Are you ready? Let's begin. What is the first picture all about? Correct. It is a moving car. How about the next illustration? Great. There are trees blowing by the wind. Can you guess the last one? Amazing! It's a man walking with face mask. As pandemic occurs, we have to follow the health protocols by wearing face masks, face shield, social distancing, and most importantly, always wash your hands. People and objects are moving anytime, from one place to another, can slow down, speeding up, and changes directions like the moving car moves at constant speed, as well as the man walking on certain direction. They are exhibiting motion. It includes its descriptors such as distance, displacement, velocity, and acceleration. Congratulations! You got it all right. At this point, let's proceed to our objectives. At the end of the lesson, you can say that I can infer that waves carry energy. I can demonstrate understanding waves as a carrier of energy. To start with, let's have a body exercise. Just follow the instructions as the dance instructor guide us. Let's do the bodies waving.
Hey, what's up guys? It's Matt Stefanino with Dance Tutorials Live, and today I'm going to teach you how to do an arm wave. So to learn this arm wave, we're gonna break it down into 4 parts. Your shoulder, your elbow, your wrist, and your hand. First, we're gonna start with a simple exercise to just get some control of our arms. So you're gonna go shoulder, lift it all the way up. Then you're gonna pick your elbow up and push your shoulder down. So notice how I have this 90-degree angle here. You wanna make sure your hand isn't here or out. Shoulder, elbow, nice and clean. Then you're gonna go out to your wrist and make sure that that hand is flat, and then roll it out through your fingertips. Let's try that one more time. You go shoulder, elbow, wrist, and release. Other side, 6, 7, nice and slow. We go shoulder, elbow, wrist, release, little faster. 6, 7, 8, you go shoulder, elbow, wrist, release. So now that you have that, we're gonna smooth it out and try it a little bit faster. Ready? 6, 7, 8, shoulder, elbow, wrist, release. Other side, 6, 7, 8, shoulder, elbow, wrist, release, and faster. 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. This is an important exercise because it starts to teach you how to move one part of your arm at a time. Now we're gonna bring our arms up and out to the sides so that we can work on getting this wave to go across from one side to the other. So now, remembering what we learned in the first exercise about isolating each part of our arm, we're gonna think of this line as being our base. We're never gonna go below this line when we do an arm wave. That's really important because a lot of people wanna go down with their wave. We wanna go up. So starting with our hand, I'm gonna lift my hand up, and then my fingers are gonna come down and my wrist is gonna go up. So remember this line, nothing is below it. Then I'm gonna flatten my hand out and I'm gonna lift my elbow up. So shoulder is down, hand is flat, and just my elbow is high. A little tip for this one, if you can't get your elbow quite as high as I just had it there, it'll help if you rotate your elbow to the front. So I'm turning my arm this way and still keeping my hand flat, and that allows me to get a really nice high angle with my elbow. Then the last part is I'm gonna press my elbow into my shoulder. So notice I'm not pushing my hand away to get my shoulder up. I'm actually pushing this bend into my shoulder. So if you have to take your shoulder behind your ear a little bit, or even lean your body, it's okay. You just wanna make sure that this hand doesn't move. So let's try that whole thing again, nice and slow, connecting it. We go 7, 8, you go hand, wrist, elbow, shoulder, reverse it, elbow, wrist, hand, release. Little faster, 6, 7, 8, we go hand, wrist, elbow, shoulder, elbow, wrist, hand, release. Nice, now, it's not gonna do us much good if we can only wave on this one side. So, let's try the other side nice and slow. Starting here, remember this is your baseline. Nothing goes below, only above. We go hand, then you wave it down to your fingers, lifting your wrist up. You go elbow, keeping that hand flat, and then shoulder, make sure that hand stays still. Reverse it back, elbow, up to your wrist, out through your hand, and flat, a little faster. 5, 6, 7, 8, you go hand, wrist, elbow, shoulder, elbow, wrist, hand, down. Good. So practice this a bunch. It's really important. So now that we have both sides individually, we can take our wave from one side and pass it over to the other. So we're gonna try it just like that, keeping it nice and clean and going across. Ready? 5, 6, 7, 8. You go hand, wrist, elbow, shoulder, switch, shoulder, elbow, wrist, release. Again, hand, wrist, elbow, shoulder, shoulder, elbow, hand, release. So now I'm gonna give you a little challenge and we're gonna speed it up. If you're new to waving, don't worry if you can't do it right away. It takes a little bit of practice, but it's important to have something to work towards. Even if you're an experienced waver, this is a great drill and something that I do every time I practice to work on my waves. So here we go, 5, 6, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. How'd you do? It's fast, I know, but trust me, once you get it, this is gonna make your wave so smooth. Let's try it one more time. 5, 6, 5, 6, 7, 8. Ba 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 ha ba 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 ba. All right, so you've got the technique down, but you might be thinking to yourself, this doesn't look like a wave yet. It's just a bunch of random positions. You're right. We have to smooth it out and make it nice and controlled all the way through so that we get our wave. The good news is this is actually easier than learning the positions. All we have to do is fill in the gaps. So bringing your arms up, we're gonna go 1, 2, elbow, shoulder, don't stop, keep it smooth. You'll notice that as I do it slow, I'm still hitting all of these positions. So if you pause me here, you'd see that elbow, just like we worked on before. If you pause me at my wrist, you'd see this with nothing below this line. So make sure when you're practicing and smoothing them out that you still keep your technique. Let's try it again. 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Again. 1, 2, 3, 4, 5, 6, 7, 8. All right, if you can do it slow, there's no reason you can't speed it up. So let's give it a shot. 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Again. 1, 2, 3, 4, 5, 6, 7, 8. So now that you got it down, we're gonna put some music on. We're gonna start with just our clean isolation going across slow. We'll speed it up a little bit, and then we'll try and smooth it out. We'll also have a little fun and freestyle at the end, just so you can get some ideas of different ways to practice your waving. Let's try it. Great job.
What was the dance instructor taught us? Very good. It is the arm wave. What parts of the body does the dance instructor focuses on the tutorial? Amazing! It is arms, hands, elbows, shoulders, and neck. Did your body warm up on the exercise? Good! Now, let's proceed to our next activity. Let's have an interactive game. Are you excited? Great! The game title is Space Race. You have to choose one, the rocket ship or the alien ship. This is how to play it. You have to answer the set of questions given. Each answer questions will make your ship to move and proceed to the next destination. Your goal is to reach Mars first before the rival ship to be a winner ship. Come on, let's play!
Great! You chose alien ship.
These are the planets which contains the questions. You have to click every one of it and then it proceeds to the questions asking on the game. Good luck! Number 1 question. What's this? Very good! It is a radio. Number 2 question. What's this? Correct. It's an X-ray film of lungs. Number 3 question. What's this? Very good. It's a microwave. Number 4 question. What's this? Amazing! It's an infrared camera mobile phone. Number 5 question. What's this? Great! It's a portable Bluetooth speaker. Number 6 and last question. Who is this? Amazing! It's a surfer. Congratulations! Your ship wins! Hooray! Do you enjoy our game? Great! Now let's proceed to our activity time. You have to answer the set of questions and write it in an intermediate pad or any paper that you have. Also, you have to write your full name and section on it. I will give you 5 minutes to answer. Afterwards, I will be posting the answers on the screen. Good luck! Is this your answers? Congratulations! If not, it's okay. You can do it better next time. To fully understand it, let's proceed to our discussion. Are you ready to listen? Great! Our lesson for today is all about waves. What is a wave? A wave is a disturbance that carries energy from place to place. A wave does not carry matter with it. It just moves the matter as it goes through it. A wave is a rhythmic disturbance or movement that transfers energy through matter or space. Waves carry energy, not matter. A wave exists as long as it has energy to carry. Always remember that. What is a medium? It is a substance through which a wave can travel. For example, is the water, people, air, and cold wine. These are two classifications of waves. First, according to movement or propagation, or direction of movement. Second, according to medium, or need of an object for traveling of waves. According to medium of propagation, there are two types, mechanical wave and electromagnetic wave. According to movement or propagation, there are also two types. It is longitudinal wave and transverse wave. What is a mechanical wave? It is a wave that requires a medium. For example, the sound and water. Mechanical waves must have matter to travel through. One example of mechanical wave is a surface wave that propagates along the interface between differing media. A common example is gravity waves along the surface of liquids, such as ocean waves. Gravity waves can also occur within liquids, at the interface between two fluids with different densities. There is also a circular movement in transferring energy. Now, what is electromagnetic waves? It is a wave which is capable of transmitting its energy through a vacuum, for example, empty space, produced by the vibration of electrons within atoms on a sand surface, travel through space until they reach Earth. These waves subsequently travel through the vacuum of outer space, subsequently reaching Earth. In electromagnetic wave, there is electromagnetic spectrum. It's a range of all types of EM radiation. Radiation is energy that travels and spread out as it goes the visible light that comes from a lamp in your house, and the radio waves that come from a radio station are two types of electromagnetic radiation. The other types of EM radiation that make up the electromagnetic spectrum are microwaves, infrared light, ultraviolet light, X-rays, and gamma rays. You know more about the electromagnetic spectrum than you may think. The image below shows where you might encounter each portion of the EM spectrum in your day-to-day life. The previous image shows the examples of materials using electromagnetic waves, such as the radio, microwave, infrared, visible light, ultraviolet radiation, X-ray, and gamma ray. Your radio captures radio waves emitted by radio stations, being your favorite tunes. Radio waves are also emitted by stars and gases in space. Microwave radiation will cook your popcorn in just a few minutes. It is also used by astronomers to learn about the structure of nearby galaxies. Night vision goggles pick up the infrared light emitted by our skin and objects with heat. In space, infrared light helps us map the dust between stars. Our eyes detect visible light. Fireflies, light bulbs, and stars are all emit visible light. Ultraviolet radiation is emitted by the sun and are the reason skin tans and burns. Hot objects in space emit UV radiation as well. A dentist uses X-rays to image your teeth, and airport security uses them to see through your bag. Hot gases in the universe also emits X-rays. Doctors use gamma rays imaging to see inside your body. The biggest gamma ray generator of all is the universe. Now let's proceed to another classification of waves according to movement or propagation. Under this is transverse waves. Are waves which travel in a direction perpendicular to the direction of vibrations. In a transverse wave, the medium or the material the wave is in moves back and forth at right angles to the direction the wave travels. These are the parts of a transverse wave. First, the crest, the highest point of a transverse wave. Next, the trough, the lowest points on a transverse wave. Next is the wavelength. The wavelength is the distance between one point on a wave and the nearest point. Another is the amplitude, the maximum distance the wave vibrates from its rest position. Amplitude is a measure of the energy carried by the wave. The more energy a wave carries, the higher the amplitude. It is also the height of a wave. Always remember, high energy waves have high amplitude, and low energy waves have low amplitude. Next part is frequency, the number of waves in a given time. Last but not the least, the period. It is a specific time a wave will happen. Last types is longitudinal waves. Are waves which travel in a direction parallel to the direction of the vibration. The wavelength of a longitudinal wave can be measured as the distance between the center of two compressions or rarefactions. These are the parts of longitudinal waves. First, compression, the region in a compression wave where the medium becomes crowded together and more dense. Rarefaction, the less dense region of a compression wave. The more closer the waves are, you can barely see their compression. The more they are far away, you can see the rarefaction of waves. Water waves are a combination of longitudinal waves and transverse waves. Based on discussion, what have we learned? Great! Waves carries energy, not matter. Can you give me one example of waves that you observe on your surroundings? Amazing! To sum up, please watch the short video.
Ever seen a Mexican wave at a sporting event? The effect is a pretty cool display that goes all around the stadium, but no one has had to move seats. All waves can transfer energy from one place to another without transferring any matter. This is done by a series of disturbances or vibrations that carry the energy. Just like the people in their seats, only moving up and down when it's their turn. Waves can transfer energy through solids, liquids, gases and empty spaces, otherwise known as vacuums. There are two types of waves, which we look at in more detail in another video, but the basic features are the same. These four words describe different properties of waves. Let's discover what each one means. The frequency of a wave is the number of complete waves passing a fixed point in a given amount of time. This time period is usually 1 second. This is what one complete wave looks like. So if this was our time period, the frequency would be 5. Frequency is given the symbol F and is measured in units called hertz. Hertz measure how many complete cycles per second. So how many people in our Mexican wave stand up every second. The frequency and period are often confused. The frequency refers to how often something happens, whereas the period refers to the time it takes to happen. The period of a wave is the time for one complete cycle, so the time taken for one person to stand up, wave, and sit down. This would be measured in seconds. When something happens repeatedly, we say that the event is periodic and refer to the time for the event to repeat itself. The period of the Earth to orbit the Sun is 365 days. The period of a day is 24 hours. The period of a typical class at school is 45 minutes. Now for wavelength. The wavelength is the distance between a point on one wave and the same point on the next wave. For example, two peaks or two troughs. Wavelength is given the symbol lambda from the Greek letter and is usually measured in meters. Wavelength can vary hugely in size. X-rays are very short, visible light is here, and FM radio waves are much longer. So we've looked at the frequency, period, and wavelength so far. Let's finish with amplitude. As waves travel, they create disturbance. The amplitude of a wave is the distance from the maximum disturbance to the undisturbed position. Think of a very flat sea, and then an incoming wave. The amplitude is the height of the top of the wave from the flat sea. Can you add the labels to these waves and work out the frequency? Notice that the top one is distance and the bottom one is time. Pause the video, work it out, and click play when you're ready. Did you get them right? In another video, we'll be looking at wave speed equation and connecting wavelengths and frequencies. For now, you just need to know what these 4 key words are.
To evaluate what have you learned, answer the set of questions. Choose the best answer. I will give you 5 minutes to answer. Good luck! Is this all your answers? Congratulations! You did great! End quote for today. Sometimes in the waves of change, we find our true direction. And that is all. Thank you for listening. Happy learning. See you next time. Bye!